So welcome all to the lecture Organic Reaction Mechanism, and in this we are discussing the topic free radicals, how they are generated, and we have learned about their stability and how they are reactivity or how radicals are reacting or free radicals reacts in the chemical reaction. Okay, fine. So let us go for the next point is what about the uh, how the hydroperoxide organic hydroperoxide, how they can be converted into uh, free radicals and how free radicals can be synthesized and how the free radicals can be converted into different types of products. So in this lecture we will learn different we will learn about different precursors or different organic moieties, different organic compounds, molecules, how they undergo decomposition in the presence of certain initiator or some suppose say like sunlight or high temperature. So one of them is hydroperoxide. What is a hydroperoxide? You see, it is the very good example of hydroperoxide. When there is a oxygen-oxygen linkage, when there is a presence of oxygen-oxygen linkage, and one side of oxygen there is a hydrogen, and another side there is a presence of alkyl group. This alkyl group R. Okay. When you heat these such compounds, hydroperoxide compound at high temperature, free radical formation takes place and results in the formation of ketones. So hydroperoxide on decomposition undergo free radical reaction mechanism and they form ketones. So how it is taking place? So let us go for mechanism. So very simple. When you heat this, there is a breakage of peroxide linkage. You can see there. This breakage takes place and generation of free radicals. OH loss. There is a radical generation here. This OH radical further try to abstract the hydrogen which is attached here. You see at this carbon there is a one bond with oxygen, one bond with ring, one bond with methyl, and fourth bond is with hydrogen. You can see. So this hydrogen abstraction takes place by this OH radical by the same mechanism of free radical or homolytic fission. And then there is a generation of one radical here. This radical, there is a formation of bond. And in this way, we can explain how the organic hydroperoxide can be converted into ketones. Okay. So let us take one more example. So hope you understand this example. Okay. Water loss takes place. Let us go for the another example. See, the one more example before you. Okay. Is a bicyclic compound. And you see there is a hydroperoxide. What is hydroperoxide? Hydrogen and peroxide. Hydroperoxide. Hydroperoxide. Peroxide means oxygen-oxygen linkage is called as hydroperoxide. This is oxygen bond and hydroperoxide, and this is alkyl group. Whole this big one is alkyl group. This one is alkyl group. So you can think about it. Alkyl group. You see how this is this much. This much total big group is alkyl group. Okay. So this alkyl group is consist of a very complex part, we can say very large part. But when you studying this reaction, it's very easy to understand. Very easy to understand. There is a breakage of this bond, OO bond, right? There's a formation of free radical here. So we should know this one, that when this bond break, one radical here, right? Yes or no? One radical will form. Okay. So one radical will be here, one radical will be here, this bond break. Then what will happen? The carbon at which this oxygen is attached, there is no hydrogen because one side methyl, one side carbon, one side carbon. So which bond will undergo breakage? This bond will break. When this bond will break, you see this one, this bond. So when this bond is break, the radical generation takes place at this carbon and at this carbon, and and there is a formation of double bond. So C double bond O, you see, you can see it. Okay. You see, okay. So you see when this bond is breakage takes place, generation of radical takes place like this. First step. Second step, breakage of this bond break, and generation of radical here and here also. This form double bond. You can see double bond and methyl is here. And what about this one? This is CH2 now. This CH2, we are taking alkane as a solvent or proton donor or hydrogen donor. This one takes this H and that becomes CH3, and this R gone with this OH, and that will form alcohol or other compounds. So it's a very simple mechanism. So you can observe this one. So you see, first of all, homolysis. This half-headed arrow is nothing but the showing that homogenetic cleavage, okay, man, which results into the formation. See, there is a loss of OH dot hydroxy free radical. Then this this oxygen carry radical, the negative part. Sorry, one that radical means one dot. Then this bond undergo breakage, you see, by homolysis, and the generation of radical at this carbon convert to double bond. You see, like this. And after this, there is a formation of this radical bond, double bond carbonyl. This CH2 extract hydrogen from the solvent, that becomes CH3, and this is nothing but equal to like this, and this one is same. You see, this one is same. How it is same? You can give numbering and you can find out their IPC name. No problem. See how you give numbering 1, 2, and 3, and 4. 4-membered ring. One white first carbon, there's a carbonyl. So 1. Second carbon 2 methyl. This is 2. 3 carbon ethyl group, and 4th carbon nothing is there. So by writing the IPC name of 2 different compounds, it is easy to show the similarities and differences between the compounds. So it is a very interesting example before you, how the how these how these molecules how these molecules are undergoing the hydroperoxide. The hydroperoxide, okay, hydroperoxide. Remember, hydro means hydrogen, and peroxide means this oxygen bond. Peroxide, hydroperoxide. So, like these examples, many examples are available in the literature. So you can collect the information You can take the examples and you can practice for these questions. So like this hydroperoxide undergo into the free radical mechanism or pathway and converted into ketones. Remember ketones. Let us go for the next discussion. That is what? Now decomposition of dialkyl peroxides. This box, ये box आ रहा है आपको ठीक से दिखाई नहीं दे रहा है. Yes. Now it's okay. लेकिन box आ जाएगा. See decomposition of dialkyl. हमने इससे पहले क्या देखा है? Hydrogen peroxide means oxygen oxygen linkage. हमने इससे पहले जो देखा है, what is that? Oxygen oxygen linkage, one side hydrogen, another side alkyl, but both the side alkyl groups. That is called as dialkyl peroxide, or we can say free radical reaction in dialkyl peroxide. So what is the product of alkyl peroxide or hydroperoxide? Ketones are the product, right? Ketones and water is the product. Ketone is the main product, water is the byproduct. When we talk about the dialkyl peroxides, they also produce ketones and as well as alkane. It's very important, very interesting. Dialkyl peroxides, they produce ketones and alkane. So fixed products of dialkyl peroxide undergoing free radical mechanism. When they undergo free radical mechanism, these are the fixed products. Let us go for example. You see tertiary butyl peroxide. You can see what is the name? It's a tertiary butyl group, and it is what? The peroxide. So dialkyl means di-tertiary butyl peroxide. When you heat it, what products we are expecting? So it is what? The acetone and ethane. Mechanism is very interesting again. Always remember, peroxide linkage is a very weak linkage and undergo breakage easily. And there is a generation of this bond break and generation of radicals, tertiary butoxide radical, tertiary but oxide, tertiary but oxide radical, two will form two radicals. Now next step, this tertiary butoxide radical undergo the cleavage at the carbon, tertiary carbon and carbon-carbon cleavage, and it will form the final X1 product, that is a carbonyl means ketone, acetone here, and there is a generation of methyl radical. So one tertiary butyl oxide radical, see, one tertiary butoxide radical producing one methyl radical and one acetone. So two tertiary butoxide radical, two tertiary butoxide radical, they will definitely produce two methyl radical, right? Yes, and two acetone. So these two methyl radicals, they combine and they form ethane. So by using different examples, we can explore our idea how the dialkyl peroxide can be converted into, how this can be converted into, this oxide can be converted into the final product, acetone, is acetone, and ethane. So you can see for 2 minutes in this reaction how the dialkyl peroxide converted into the corresponding ketones as well as alkane. Okay, fine. Let us go for the next reaction with the free radical substitution reaction, and we are very well versed with this. We know the halogenation of alkane. We are familiar with the halogenation of alkane. Yes or no? Yes. We know methane and the reaction with the chlorine in the presence of sunlight. It produces alkyl halides and it continues dialkyl halides, sorry, dihaloalkane, trihaloalkane, tetrahaloalkane, and so on. Means polyhalogen derivatives, monohalogen derivatives. We are well known about this. But here we are just here to explain the reactivity order of halogens, because we have seen that in the previous lecture. You can watch this on YouTube. That halogens also provide a method for the generation of free radical. So out of 5 sources, halogen is one of them. When halogen reacts in the presence of light, they provide a free radical based mechanism. We have seen this in the last lecture. Therefore, when halogens say fluorine, bromine, iodine reacts with any alkane or hydrocarbon, so their order of reactivity is like this. Fluorine reacts with explosively, fluorine reacts with moderately but very reactive compared to bromine and iodine. Okay. And when we go to the type of carbon present in the alkane, say primary carbon, secondary carbon, tertiary carbon. So remember, tertiary carbon always react faster with the halogen by radical mechanism compared to secondary carbon, and it is more reactive than primary. So these two order must be remembered to understand the free radical substitution reaction. If you think about isobutane or isopentane, if you say isobutane or isopentane, say here, we will take isopentane, better isopentane. Now see, in this, all 3 types of carbon exist. What are the carbon? You see, this is a primary carbon or not? This is also primary carbon here or not? This is also primary carbon or not? This is what? Secondary carbon, and this carbon is tertiary carbon. Now, see, if we are reacting this with chlorine, no problem. We can write chlorine here, no issue. Or we can write fluorine, bromine, no problem. Chlorine, Cl2. And sunlight or heating, no problem. Sunlight or heating. So what is the monochlorination product? Means which carbon will react with chlorine? The tertiary carbon. So the major product or the first product would be this one, and HCl. HCl means one Cl from this and H from this. When we use only one chlorine molecule and one this isopentane, so that tertiary carbon would react. It's the monochlorination. Larger product will be this one. Major product will be this one. So like this, we can understand the idea of reactivity order between the halogens as well as alkanes. It is also observed from the different examples that fluorine and chlorine reacts very fastly, therefore they are less selective. Means there is a formation of major and minor products. Okay, remember, but in a not much more difference. But when you talk about bromine and iodine, they are less reactive, therefore they are highly selective. If you are doing the reaction of, suppose, if we are doing the reaction of, so many examples are there, which is isobutane with bromine. See, isobutane with bromine. Now we are trying to understand the meaning of this sentence, this statement we are trying to understand. So now you see, two products are possible. One product is what? This one, bromine at tertiary carbon and at this carbon. So see, both will form, but which will form in more amount? This will form. We can say more than 90%, 98%, or this will form 2 to 5%. Okay, less than. So this is the selectivity, means this will form in more amount. But instead of this bromine, if you take chlorine here, if we take chlorine here and same compound, so definitely chlorine will attach to this tertiary carbon first, and another product would be like this Cl here. But what is the percentage ratio? This will be almost about 90%, and that will be 10%. Which one is 10%? This one is. So this is called as less selectivity. Less selective means chlorine is less selective because it is highly reactive, therefore it will attack here and here also. While bromine being less reactive, it is a more selective, therefore we can say the higher product is what? Always in high amount or high percentage. Next reaction is what about the free radical addition to olefin. This is a very interesting reaction involving free radical and how addition to olefin. Olefin means alkenes. Olefins means alkenes. So always remember, any free radical reaction, any type of free radical reactions, it requires initiator, chain initiator, or we can say accelerator. In polymer sciences, I mean all the polymers, many, may not all, many polymers are prepared from addition polymerization, that is from alkenes, and therefore they require very numerous types of catalysts as a accelerator or promoter of the reaction, or we can say the initiator of the reaction. So here, this AC2O2 means, and what is the meaning of this BZO2 means? This is a acyl peroxide or benzoyl peroxide. How to draw a structure? You should know this. This is acyl. Okay, so this is really highly reactive. Suddenly undergo radical formation. Okay, by breakage of this bond breakage, and radical will form. What is BZ2O2? Remember, it is like this. There is not much more difference. Just like this. Here we have phenyl ring, and here also we have. So this is any one of them can be used. So in polymer chemistry, polythene preparation, or many types of polymer formation, we use generally this benzoyl peroxide. It is called as benzoyl peroxide as a initiator. Okay, so in olefin reaction, we use benzoyl peroxide as a chain initiator. Okay, see, See, the reaction before you is this one. So we have taken olefin and one carbonyl compound, say aldehyde, initiate. What is the job of this initiator? Initiate the reaction and this final, you see the final product. And how to understand this mechanism, you see. First of all, initiation takes place. This aldehydic bond, carbon, hydrogen, undergo breakage. This one. Two radicals will form. And that radical of carbonyl attacks olefin sites and definitely it will form. It will attack out of this two carbon at this carbon because this is generation of a stable free radical. That radical abstract this proton and final product is this one. I hope all of you understand this free radical addition to olefin, how it is takes place. See one more reaction before you. It is not olefin addition to olefin, but it is addition to between the two carbonyl compounds. And you can see how it is formed. Here we have to use two molecules of this one. Two molecules will react. Use them. Okay. First of all, chain initiation. How the breakage of this bond takes place because of this benzyl peroxide. Benzyl peroxide undergo cleavage, homogeneous cleavage, and form reactive free radicals. These reactive radicals initiate the breakage of this bond, which form free radicals. These free radicals interacts with the other precursors. You can see here. So double bond, addition to double bond takes place. You can see this breakage takes place. This oxygen joins in ester in the form of ester, you see, and that radical is generated here. Similarly, this radical now propagate the reaction. How? Very easy now. Now it's very easy. See, this one. This actually this bond has to break, not that one. This bond has to break. Okay, this bond has to break. This one has to break. This one. So there is a generation of linkage of this bond and this carbon. You can see here. And these two radicals, they form a bond like this. You can see here. This like this. So this is another example of addition to double bond, multiple bonds, which is initiated by free radical mechanism of radical formation. Okay. Okay. Yes. So you can see here how these are formed by the mechanism involving radical formation. Right? So you should know the simple idea how these, suppose they are given like this compound. You can write this mechanism. It's very simple. It's a mechanism. Okay. So next reaction is what? Addition of dinitrogen tetroxide. So one more reaction. how the N2O4 can be added to olefins. So olefins addition reaction or multiple bond addition reaction. So very simple. The dinitrogen breakage takes place by there is a linkage between nitrogen and nitrogen, and that nitrogen bond breakage takes place, and generation of nitro NO2 radical, nitrogen dioxide free radical, and these free radicals attacks this carbonyl double bond carbon double bond carbon, and they form uh, cis dinitro, or we can say vicinal dinitro compounds. These are vicinal dinitro compounds. Similarly, one more reaction you can see. So you can imagine, you can simulate. It's again vicinal dinitrocyclopentane can be discussed. So we can change this. This is an initiator. This is also initiator. Remember. Okay. So one more reaction you can have. You see. So variety of examples can be discussed. Can be to understand the mechanism or fate of the free radical induced reactions. Okay, right. So now see, this is a trans product is stable. In this case, trans is stable. Okay, trans product is more stable. Fine. Addition to thiols. Addition to thiols, just you can have like this. It is similar to other reaction just we have seen. Trans and cis always remember. Trans product is always major and is visible. Okay. So cyclohexene becomes cyclohexane, and this H of this SH and this SR attached like this. So one more example is there before you. Okay. So mechanism is also given to know the mechanism. You see, first of all, this breakage initiator break this SS bond, S attacks here, radical generation, this radical bond formation. This radical takes the hydrogen